Webinar produced by CCS Europe, Carbon Capture and Storage Europe. I'm Chris Davies, and CCS Europe is an advocacy body bringing together industry and environmentalists to inform policymakers of the urgent need to deploy CCS technologies if we're to cope with the problem of carbon capture, to deal with the problems of carbon capture, to deal with the problems of climate change, particularly for dealing with emissions from hard-to-abate industrial sectors. So welcome, thanks very much for joining us. We're going to today discuss, I suppose, the most fundamental question of all. Does carbon capture work? How do you make it work? And what about the allegations from some environmentalists that it's an unproven technology, an immature technology, a means of simply propping up the fossil fuel industries, a scam, I read most recently. So here's three people with us today who technology experts each. Cato Christiansen, Chief Technology Officer from Capsol Technologies. Jeremee Wetherby, Project Manager, Energy Technologies with GE Vernova. And Gianluca de Federico, Leader in CCS demands with Baker Hughes. Well, thank you. Okay, I've been working on CCS since 2008. And I have to admit that I've never really understood the chemistry. So Cato, tell us, no, Jeremee, you tell us. How does it work? I mean, how do you capture CO2?
It would be my pleasure, Chris. Thank you for inviting me this morning. Good morning, good afternoon to everyone who's joined the webinar. Just very quickly, carbon capture is not a new technology. It's been around for decades, and there's various technologies that are actually available to do carbon capture. One of the most common technologies that's used in the industry is a solvent-based, where you're going to be using a liquid with a chemical embedded with the liquid to actually capture the carbon molecules. This process is very temperature sensitive. So fundamentally at one temperature, this liquid will actually absorb the carbon molecules that are in the air, in the exhaust stream, where this effluent is being treated. In the space that I'm in, I'm tied to gas turbine. So we would basically take the exhaust gases from our gas turbine, run it through what's called an absorber, where the gas basically goes one direction, and we shower that gas with this liquid solvent to then capture those carbon molecules in that liquid. That liquid is then collected at the bottom of the absorber, and then we move that to what's called a deabsorber, where then we actually heat that liquid back up and very simply boil off the CO2 that's embedded in that liquid. With that boil off, we can then capture that CO2, compress it, and then ship it off-site via either, to a sequestration site or a utilization sector that can use that CO2 going forward. So that's at a very, very high simplistic level today.
Okay, but these solvents, do they capture all the CO2?
So as a chemical engineer, this is all tied to basically a resonance time in a reaction. So you want to size these absorbers so that the gas in the liquid amine or liquid capturing agent has time to capture that CO2. As you look at various markets and industries that have different levels of carbon concentration in their gas, you're going to size those absorption systems to account for the level of capture that you want to get out of the system. Today, in our space, in our market, 95% capture is the standard that all of our projects that we're working on going forward. So our intention, even though the concentration of a gas turbine is really low at roughly 4%, these systems are being designed to capture 95% of the CO2 that's being generated from the gas turbine.
Okay, that's very helpful. And the solvent you're using is amines?
So today we're using amine based, but I know my peers have other technologies that they are interested in, they use as well.
And amines have been around a long time?
Yes, they've been around a long time. There's many companies that have them available in the market. We're actually looking at some of the future technologies, given that amines and liquid solvent-based technologies have been around for such a long time. we're actually starting to explore what's called absorbent technologies, where instead of using a liquid, you're actually using a solid that will capture that carbon. Very similar concepts, but instead of actually moving liquid around and using liquid as the capture agent, you're just using something that looks more like a filter, where you've embedded it with a solid-based chemical to capture that carbon. Why this is interesting to us, and it's primarily being focused in the direct air capture space, because it's really good at capturing low concentrations. And that's our challenge in the gas turbine space, because we tend to have a lower carbon concentration versus other industries and markets. So if we can get it to work in a direct air capture application, it'll work much, much better in a gas turbine application. Okay. The other reason why we're focused on this technology is with the liquids, one of the key challenges is you actually spend a lot of time heating and cooling the water that's carrying your chemical. So if we're able to get that water out and just strictly right focus on the capture chemical, that saves a tremendous amount of energy in this system and makes the overall system more efficient.
Right, you raise issues we'll come back to. Thank you very much. Cato, I mean, okay, amines, they're the ones that, most of the carbon capture plants, I think, in operation at the moment are using amines. But yeah, your company, Capsol Technologies, you're doing something different. Yeah, is it fundamentally different, or tell us?
They are related, I would say. You know, we use a chemical called potassium carbonate. So it's an inorganic salt, basically mixed in water. It is also an old sort of process. It was used, you know, and developed for gas processing and high pressure gases, chemical industry, fertilizers, and so on. Some originally in the US, I think the earliest patents is around 1947 or something like that. So it's an old technology, and 1,000 plants or so in the you know, treating industrial gas streams, removing CO2 at high pressures. But it's not been used so far in post-combustion applications. There is one project, that is the Stockholm Exergy project in Europe, where they have selected our technology, and we will do it with post-combustion. Our solvent is, you can say, it binds the CO2 not as strong as your post-combustion amines. So we need some kind of driver to enhance the reaction, to speed up the reaction between the CO2 and our chemical. We do that actually by compressing the gas. So we take the flue gas and raise the pressure and put it to a level where the potassium carbonate technology has been used for years. So we are, you know, that's why we also know that it will work, because it's the same conditions for the flue gas as it's been in 1,000 plants that are in operation.
Okay, but why would someone turn to you rather than, you know, or someone?
Yeah, it's a variation of, we see different. One of the things with our solvent, this is an inorganic salt, which I say, and it has a bit different environmental profile. You know that some, you know, amines, although you can just build, it's more an engineering problem, and you can build and you can make sure you don't have any emissions of any harmful components. It is a bit simpler with our solvent, that these harmful components are just not generated. So you for an owner, some of the emitters, you know, CO2 emitters that comes to us and say, okay, it's simpler for us. We don't need to think about it. It doesn't degrade into any harmful components. So that's one thing. And we have designed the process. That's really where we work. How to make this process energy efficient. So we see that, you know, especially for the applications on when your CO2 concentration is a bit higher than the 4% that Jeremee was talking about. For cement, for biomass, waste to energy, and so on, you might be 10, 15, 20% CO2. Then our energy numbers becomes very, very low. So we can get lower energy numbers.
Right. Okay. And Gianluca, Baker Hughes, are you making capture plants, or are you doing all the other bits of the technology? You know, the pumps and the compressors and all the rest.
we are doing, I would say, all of it. I mean, starting from what Cato has just said, he mentioned that the flue gas needs to be compressed in order to enable the hot potassium carbonate technology to work. And there we have a portfolio of compressors. We've been compressing air for many decades, and we have many references, and flue gas is nothing else than air with a slightly different composition. At the same time, we do have also technologies for capturing, so the core, which is, let's say, called, I mean, the technology we are promoting now, it's called the chilled ammonia process. We've just been securing a feed for a large-scale carbon capture plant in the US with NPPD on a coal-fired power plant, 700 megawatt capacity. And this technology was developed for actually coping with the issues which we just been mentioning, namely the degradation, so the emission of contaminants. So our technology has got only one molecule that it's introduced. It's ammonia. So you can only have ammonia emissions if you like. And typically ammonia is controlled below 10 ppm easily. And this is also a chemical used in a majority of power plants for controlling NOx emissions. At the same time, this technology is able to cope with very contaminated flue gases like coal-fired power plants, biomass, where you have, let's say, NOx, SOx, and other elements that might impact the chemistry. And therefore, this technology from both tolerance to contaminants and not emitting any unwanted contaminants to the atmosphere, it's very, very solid, very, very well, let's say, positioned. At the same time, as you referred, we've been also successful in deploying CO2 compressors because, of course, CO2 needs to be brought to the storage site. We have secured a few orders in the last 2 years for large CCS projects in Australia, in Malaysia. So,
let me just, Gianluca, let me just interrupt then. Just tell us then, once this CO2 is captured, whether you use amines or alternatives, what happens to it? I mean, how do you move it? Is it a gas or is it a liquid, or what do you do to it?
You have two choices, two ways of doing that. In the US, we see pipeline transportation more common because there are already CO2 pipelines that have been deployed over the last decades for NSO recovery. So they're leveraging that also for going to storage. So gas phase, it's the choice. In Europe, we see that the majority of the reservoirs or the storage sites are being deployed in offshore. And to get there, you can either have a pipeline, like for instance, Portos is doing, developing a pipeline, or Northern Lights transporting it in a liquid form. So when you liquefy it, you have to bring the CO2 to a certain level of pressure and temperature, low temperature, and that means that the properties of the CO2 are becoming those of the liquid. So these are the two ways. And one thing I can add on top of it is that when we apply our technology, the chilled ammonia process, we do release CO2 at 20 bar. That is different from other technologies that are releasing CO2 at 1, 2, 3 bar. These allow us to directly liquefy the CO2 without having to install a liquefaction unit. So there is a benefit in saving some energy and also some footprint in this respect.
Okay, all three of you sound quite confident that your technologies work. So how do you respond to the environmentalists who are critics and say this is an unproven technology? You've just described different forms of the technology, and there's presumably many other variations. I've just been reading about ionic liquid solvents, for example, and membranes and other ways of separating the CO2 out. So, I mean, but just for your own examples, how do you respond to that accusation? This is an unproven, immature technology.
Yeah, if you want.
Let me start. Let me throw that back at Jeremee.
Okay.
No problem. So, this is not a technology problem. As all of us have mentioned, this is a mature industry. This technology has been used for years in gas and air handling type of applications. All that we're discussing here is now applying it in a post-combustion scenario. So when we get into a lot of the discussions on, why certain projects didn't perform the way they expected, when you get into the details, it's not tied to technology. It's tied to things, more associated with the economics or market dynamics that would impact those plants. So this isn't a dialogue if it works. The technology has been proven. It's been proven in multiple applications and multiple scenarios all across the globe. And that's not the question at the hand. The fundamental question at hand is really more around the market drivers at the end of the day to make a lot of these projects economically viable to go forward, because they do come with an additional cost to actually capture this carbon in these applications.
Right, and quickly around, again, just rebutting the environmentalists if you wish to do so. Cato?
Yeah, and I think it is all. This is also, you know, especially if they put up things like, okay, look what happens to Petronova or to Boundary Dam and so on. I think it's one should of course always, and one should make sure, you know, all of these are first of a kind projects, right? They're doing something. You know, okay, the technology has been used in many other places, but if you look at the whole sort of value chain and everything around these projects is first of a kind, and then it's you will run into some issues. The Boundary Dam plant, I think there were, you know, you had some problems with, okay, there were some things in the flue gas that you did not expect. So okay, that's more like a project, you know, no issue that you have, that learns you that, okay, you have to make sure you have full control before you start to build. But was it right of them to build? I think so. You know, if you start gold plating and you will add on cost, and you will need to do some projects, and some of them where then you might have a period where you don't run 90%, maybe, or 95% capture. Maybe you need a year or two to really sort of sort out the birth problems of the projects, and then all technologies are like that. It's not special for carbon capture.
Yeah, I mean, you are of course right. I mean, every technology has developed as we go on, whether it's solar power or wind power.
Yeah.
We learn by doing, and we have to do, and because of the financial situation, the equations which Jeremee touched upon. I mean, the only reason we do carbon capture is for climate change reasons. You know, so therefore it's an artificial market in order to address a market failure, which is climate change, that has to be introduced, and that's where you need government support to de-risk some of these early projects. Gianluca, any comment on this though, on the accusations? Because many of the actually it's often American. You know, Baker Hughes is an American company. It's often American environmentalists who are most critical of CCS.
Yeah. Now, what I would like to add as a perspective is, if you look at CO2 capture, it is just the last step of a chain which we call environmental control, which means air quality control. We started at the beginning of last century removing SOx, then particulate, then NOx, then mercury, then chlorinic acid, and so on. And now is the last step, but the sheer size of the problem is so big, because before we're talking about milligrams per normal cubic meter. Here we're talking about percent. And Jeremee was before mentioning the gas turbine. In a gas turbine flue gas, we have more oxygen than CO2. But anyway, it's 4%. It's not 400 ppm like in air. So it's big. And so the investments are large, and the time to develop project is long. So it's just a matter of being patient a little bit and support us, as you mentioned, having more support from government, the regulators. So the technology is there, it works, it has been demonstrated. It didn't fail so far. At least we don't have any major thing on the capture I'm talking about, because of course then this is a larger topic. But this would be my perspective. It's
okay. Well, let me talk about capture, and in particular the capture rates. Now, it's been said that 95% is the industry sort of standard, but I mean, I was just reading a brochure from Air Liquide earlier, when it's looking at different applications, and they vary in the proposed capture rates from, I think, about 85, 86% to 98%, depending on where the CO2 is being sourced. So, I mean, if you're investing in a carbon capture plant, you really want these guarantees that it is going to capture as much CO2 as the manufacturers are promising. So, you said 95%, I think, Jeremee.
I think we
Yes,
also.
I love the sentiment in the comment, because that is one of the questions that come up on how confident are you? Are you sure you can capture those levels from the exhaust streams, and what's giving you that confidence? So in our particular space related to gas turbines, there's been years of development, slipstream testing, looking at exhaust streams with 4% concentration and our ability to capture that. Cato talked about boundary dam, and there's other sort of chemicals that can impact those reactions. One of the things that I would say is lucky for us in the gas turbine space is our gas turbine exhaust streams are relatively clean versus coal-fired plants that have challenges with potential other things that are in the coal. So for us, we don't have to worry about those contaminants as much. And then the other important piece of this is we've kind of talked about it a little bit and kind of walked around it, but this carbon concentration piece, the ability to capture that carbon, the lower that concentration is, the more difficult it becomes. And that's really the core challenge, at least for us, getting that around 4%. So when we're working with our strategic partners on developing these carbon capture plants, yes, we're setting a design target for 95% capture, but we're also working on technologies that will boost our carbon concentration, that'll make their systems more efficient at capturing carbon. So today, we have a project in the UK we're working on. Yes, we're focused on 95%, but with the technologies we're adding and integrating the plants together, we're actually believing that we can get up to 98% capture. And from a project perspective, we're going to guarantee the 95, but from a design and demonstration, we're shooting for 98 capture at the end of the day.
Okay. And Cato, how can you beat 98%?
No, and I'm not sure it's smart to do it, to be honest, because we also have to think of being technical people here also, that there is some physics. And this is about, for example, if you drop 10 needles in a haystack, it will be easier to find the first ones. The last needle is going to require a lot of energy, a lot of stuff you need to remove to find that. And it's the same with the CO2 molecules, right? If you want to separate 100% of the CO2, it's going to require you a lot more energy. So you need to find, so what's the optimum there? Right now, today we have 100% leakage of CO2. So let's try to get 95 and then of course improve. But I'm a bit worried if companies set too strict, we would like to have 98% all the time, then it's going to add on cost. Then technology providers like us will need to add on more stuff to make sure that we can guarantee these kind of things, because there will probably be a penalty for us if we do it. And the world is dynamic, right? Your gas turbines, your cement, your whatever, it's not producing constantly all the time. So your capture plant will need to follow this. And there will be sort of, it will follow behind, but you will sometimes maybe you do 92, other times you do 97, 98% capture. So sticking on this 95 or 98 all the time, I don't think that's a smart thing. Then we will increase cost more. But it's technically possible, yes, of course.
So, Gianluca, you're putting cards on the table?
Yeah, I have 2 points. One, you probably, Chris, might remember 15 years ago with the EPR and ER 300, we set 80% as the target. It was, wow. Then
these were both financial support mechanisms that the Commission attempted, neither of which were proven very successful, but have been overtaken by the Innovation Fund now, which is supporting a number of new developments.
Correct.
Please.
And then we realized, because the projects were developed and we understood it was possible to do more without too much of an effort. So I share everything which was just said. And the second point I would like to add is that, coming back again to the analogy with the desulfurization, for instance, at the beginning was maybe 90%, then 92, 93, now we are 98 and more, and easily achievable. So it's a matter of a learning curve. and also getting confidence from technology providers. And and at the end of the day, is eventually a compromise of setting OPEX and CAPEX, because higher capture rate will determine higher CAPEX, but lower OPEX for maybe more. So it's an offset how much investment you want to put on the project, because you're gonna get more CO2, so the CAPEX will be slightly higher, the OPEX will be slightly higher, but maybe because you have more volume, you're gonna offset a bit of this cost. But there is a point where you cannot. The increasing effort is becoming too high, and therefore you are not going to optimize. You're gonna only to increase dramatically your unitary cost.
Thank you, Gianluca. Let me just say that I'm Chris Davies of CCS Europe, and with me are Cato Christiansen of Capsol Technologies, Jeremee Wetherby of GE Vernova, and Gianluca de Federico of Baker Hughes. Okay, capture rates, that's obviously a concern for anyone who's thinking of investing in carbon capture, but they're also going to be interested in what you can say about the energy performance and how much energy is required for the pressurization of CO2 in order to enable transportation. I mean, how much does this actually take away from the potential benefits because of the energy penalties you're going to have to pay? Who would like to go for that? Cato.
I think for the compression is probably better for Gianluca, since he sells the compressors. But on the capture part, it's a range, as was mentioned a bit earlier, typically related a bit to CO2 concentration, and for our technologies especially. I of course would like to brag on good numbers we see about when we have like a cement case, for example, where you have 18%, then we would use about 170 kilowatt hours per ton of CO2. That's total energy consumption for the pre-treatment and capture process, not including CO2 liquefaction. So 160, 170 kilowatt hours per ton is what we can provide them.
Gianluca, you got an introduction there. Compressors. I mean, what about the energy penalty that you have to pay, and whether this starts to undermine the benefits that carbon capture can deliver?
It depends, of course, on the source of CO2 and how expensive or how cheap was the capturing of CO2. And this is depending on the concentration. And now, so anyway, if you look at compressor today, you should not look at that as an equipment that just does the compression piece, but also is a process unit, because there is heat, there is energy can be recovered, and this, if integrated into the chain, especially upstream into the capture, can determine quite important savings. We are also seeing that, especially in the Nordics, where DC heating is connected to the host plant, where the capture plant is being envisaged, they ask us to design the compressor as a heat pump, so to reject heat, because this heat is money for those operators, because they sell it as they would sell electricity, sell also DC heating water. So the more we can reject, the more it is beneficial for the project.
We need literally 1,000 or so carbon capture plants across Europe if we're to meet the sort of targets that are being set for CO2 capture in 20-25 years' time. It does strike me, just as you talk, the thought occurs to me that a lot of technology improvements are going to take place in that time, and a lot of suggestions like the one you just put forward, that maybe the heat can be, maybe we can generate heat that can be put to use as part of the process. I mean, are you looking around? Are you seeing these potentials, Jeremee or Cato?
Oh, absolutely. This is the core value that we're bringing to this discussion from a GE Vernova standpoint. Let's be honest, when we look at our gas turbines and our combined cycles, we're constantly optimizing the system to drive the greatest efficiency of converting fuel to energy. So this is absolutely right in our wheelhouse as far as technologies that we can bring to bear. When we look at applications of putting a carbon capture plant on a gas turbine. Just bolting the plant on, you're looking at roughly orders of magnitude, a 10% efficiency impact to our gas turbine combined cycle. That is massively significant at the end of the day. However, this discussion that Gianluca highlighted, that to integrate the technologies, to bring the two companies together and find ways to be more efficient, to use the steam and energy generated from the combined cycle power plant and use that to drive the carbon capture plant, which for us, it's basically a market we've done for years. We call it combined heat and power, where we export our steam to an industrial process and then get the water back and reheat it. We're very comfortable with that. We've been doing that for decades. And as we're looking at integrating these capture technologies with our gas turbines, we're seeing opportunities to get at least 5 points of efficiency back versus just a bolt-on solution. So there's tremendous value. And I also want to go back to something Cato said, because he's absolutely correct. The greatest value of a combined cycle gas turbine in the power industry, in the market, is its ability to be flexible. And we don't want to lose that. But as we integrate these plants together, the gas turbine can remain flexible, and we have technologies that can mitigate those carbon concentrations, those airflows of what the capture plant's going to see, so that the best use of that capture facility is to have a steady state operating mode to optimize the efficacy of that absorber. So if we can use things in our portfolio from a controls perspective to mitigate those impacts to the carbon capture plant, those are additional efficiencies that we can get out of that plant that lowers the CapEx and the OpEx that Gianluca was highlighting. So absolutely, this is where I personally spend 80% of my time on driving the best integration between a combined cycle power plant and a carbon capture facility.
And
Thank you.
We also, on the, I would say it's especially for European clients, we deal a lot with waste to energy plants, and most of them are connected to a district heating system, right? So while GE has the combined heat and power, we basically, I would say, we have a combined heat and capture plant. That's as I mentioned, we have this compressor and we pressurize the system. So we have parts of a heat engine or a power or a heat pump in our capture plant. So we do the same for all these clients that have access to district heating or somewhere they can dump valuable heat, sell it to clients. Then we configure our plant to provide both the capture and a serious amount of heat in the, say, from 100 to 50, 60 degrees that you can dump into a district heating system for a city or something like that, and get extra value out of that. A lot of these things will drive, give extra income to the projects, and not only paying for the CCS.
And we need that. We certainly need that. Tell me, I raised before the question of CO2 capture rates. Can I raise now the issue of CO2 purity rates? And in particular, the concern that some CO2 emitters have, that the transport operators and storage site operators of CO2 will require them to meet CO2 purity levels, which they think are unreasonable, which require so much extra investment and cost as to make CO2 capture just impossible to take forward. And in particular, Northern Lights, which is funded very much by the Norwegian government, and is the first main storage site going to be made available in Europe. There are complaints from some industries that it is suggesting that the purity levels for CO2 being sent to it must be of a much higher standard than the emitters think necessary. Do you have any comments on that?
Yeah, I could try to comment a bit. I think some.
You find out why not. Norwegian being put on the spot about a Norwegian project.
and I have had in my previous life quite a lot to do with that project as well. But now I would say we are, at least in I think US is probably better because they have much more experience on transporting and storing CO2 already. But if you look at in Europe, Northern Lights, it's the first kind of open source type of storage facility in Europe. And when you invest a lot of money and you get a lot of attention as the owner there, you will make sure you're not failing this thing, right? So there are really, and I don't think that maybe it's easy to put a specific standard for this at the moment. Again, we need to learn. So for the Northern Lights part, and I think for many of these first, it's a collection of input from all the various parts in the value chain. The boat will need this, the pipeline will need this, the wells will need this, this specific reservoir will need this, and then you collect it into one specification. And maybe it's too strict on some components, and maybe not. That will have to be experienced and learned as we go, I think. But I understand that if you're the first operator of this kind of transport and storage facility, you don't want to fail. It's a massive crash both to you and the business, the whole business.
Gianluca, Baker Hughes must make some of the equipment that might be sensitive to CO2 purity levels.
Yeah, indeed, and we are also active in the in the well side, in the storage side. So we do supply equipment services for storage, and one of the things we do with our customers, of course, are especially if the site is an existing site, a depleted reservoir, where some equipment is already the famous Christmas tree, and other equipment are already available. We do studies. We run studies for our customers in order to check also the suitability of the materials of which the equipment, the wellhead equipment, is made of, in order to see whether the CO2 with a given composition could be allowed. But this is a topic where I share what Cato said. There is not much of experience, especially in Europe, and therefore we see a lot of conservativeness in this respect. But at the same time, those limits are achievable.
Too conservative, do you think?
I don't think it's too conservative. I mean, what we are trying to avoid is corrosion at the end of the day, long-term corrosion. And so if we want to, to have a business that can be run for, several decades, probably being a little bit conservative helps. But of course, we will learn a lot from Northern Lights and other projects that will be run in the future. So as of today, I don't think I'm in the position to say whether it is wrong or right. The only thing I can say is that those limits, even if are conservative, are achievable.
Okay, but I mean, what happens here is that the emitters feel that they're on the other side of the fence to the people who are going to be actually storing the CO2. That maybe the people who are transporting and storing the CO2 have a commercial interest in requiring standards which are excessive. In the case of GE, though, you make plants which emit too, don't you, Jeremee? So which side of the fence do you fall on?
So it's hard, because that's really getting down to our partners that do the capturing and the purity level. So it's not something that we get into often at the end of the day. And the other thing that I would highlight is, as I mentioned earlier, the fact that it's a gas power plant. Our emissions are relatively clean at the end of the day. There's not that level of potential contaminants that are going to be in our effluent stream that would be a concern. But I think it's important to kind of go back to something that Cato highlighted, as we look at this industry, as we look at this market, there is a lot of eyes that are on us and watching what we're doing extremely carefully. And the things that we can do as a collective industry and market to manage the risks and unknowns and the things that could potentially happen, I think is driving a lot of this conservatism at the end of the day, so that in the world, especially with new applications, new technologies, things will happen, things will occur. That's just natural in the evolution when you apply projects like this. But as prudent companies, engineers, we're always looking to find ways to mitigate those risks, manage those unknowns, so that we can drive the highest degrees of success at the end of the day. So the idea of being conservative, setting requirements, is just our way of managing as many of the risks as possible so that we set ourselves up for success at the end of the day.
Thank you. Right, as we move towards an end, imagine that I am the manager, director of a industry which is seeking to reduce its emissions. It believes that carbon capture is perhaps the only way forward because the emissions perhaps are released as a result of a chemical process. There's no alternative to carbon capture. But I'm looking around at these still relatively new technologies, competing technologies, and others in the wings. And I'm thinking, even if there's a business case, even with some government support, I could be spending hundreds of millions of euros here on buying a capture plant, getting someone to build it, install it for me. And by the time it's built, it might be overtaken by other technologies. And I might be stuck with a plant which is not operating at the same efficiency as other plants for the next 30 years. Is this the time to invest? Or should I be hanging back and waiting to see what happens over the next few years? Who'd like to go with that one? Well, you go on, Cato, your Capsol Technologies, you're trying to promote this technology. Go for that.
Yeah, okay. It's a very good question, and it's of course it is. We often get in discussion with clients, some clients, and I won't say their name, of course, that they will say that we would like to be a fast follower and not anything else. So we'll sit and wait. So you have some of these, but I think there is also, there is an opportunity for these that are first now to actually, and I think we see that from some of the bigger companies that they see, okay, these first projects, they are also most likely to get some kind of, be in a funding scheme or innovation fund or anything. If it's in Europe, these are designed for the first movers to actually take away some of that cost for the first movers, because they know that it's a lot of the learnings will also benefit the ones that are not spending money there. But they will probably, those kind of funding will not be available for the next ones. So I think if you are a bit forward-leaning now, then and you will get a project with some government funding, you will also go down the learning curve as especially for I would say for the big industrial companies that have many plants, and where this is a large problem, right? They have many plants they know they will have to do CCS on. If they go in now, I think they will much better next time cut a lot of costs, because a lot of the cost is not just about buying the capture plant it's actually running the project, doing the permitting, doing everything like this. You will learn a lot as a first mover that the others probably will not get. They will get more technology, but they won't be able to do the next project as quick and cheap as you will if you take the first step, I think.
Thanks, Cato. Gianluca, are potential customers holding back?
I would say we need to hurry because there is a shortage of storage. I mean, in Europe, we have probably 2 upcoming storage sites. In the US, I think there are just few classics being awarded. So you need to book your space, your pore space. Otherwise, if you wait too long, you might need to wait much longer and be subject to the taxation and
yes.
that we know are ever increasing. So that would be an argument.
And of course, the good news is it does look as though the European Council and the European Parliament are coming close together now in backing the European Commission's target of having 50 million tons of CO2 storage capacity available per year by 2030. Progress is coming, so there could be storage sites available on a much more open and competitive basis. And GE, what's your experience, Jeremee? Are customers holding back?
I'm going to highlight what you just said, because it said 50 million tons by 2030, and now look at where we are today. We're in 2023. That's 7 years away. I'm sure all my colleagues would highlight that the time it takes to develop, procure, build, commission, and install this equipment, to do all that within 7 years is going to be very tight. That's not a lot of time. And as you mentioned earlier, that we're looking at, we need thousands of plants. So The first mover, I'm in violent agreement with Cato that there's tons of value to be a first mover, but I also see once this market isn't a question of if, it's a question of when. And when the market's going to go, it's going to go because this is a viable solution. It's a solution that technology has been demonstrated. And as these projects go in, I expect that we're only going to see more and more of them start to line up. And eventually, we're going to get into a market where we're not going to be able to support all markets and industries because it's just going to be reach capacity. So if, I look at our customers and their targets and their ambitions to hit their, ESG goals, they really need to start making decisions today because of the procurement cycles, the permitting cycles, and everything that goes along with it, so that they can get this equipment in the ground operating in line with the targets they've set for reducing their emissions from a company perspective. We're just simply running out of time, and it's going to reach a bottleneck at some point.
And what CCS Europe would argue is that we need CCS without any question in order to reach the climate change targets that the European Union has set itself. And first movers, businesses can't be expected to take the risk all by themselves. There's going to be many improvements as we learn by doing, and those first movers need public sector support, governmental support to de-risk their projects if we're to encourage them to take the leap, because others will benefit as a result of the experience they gain. Okay, very last question. You've all three of you, you've been around doing CCS work for a long time. How do you feel about the prospects at the moment? Jeremee.
I'll jump in on this one because I'll be honest, as we've been watching putting carbon capture on a gas turbine, we used to talk about one project and one project only. The amount of projects and feed studies that we're doing today is growing exponentially. Of course, in the US, it didn't help to have the Inflation Reduction Act come out that definitely boosted the value of carbon being captured. But once again, as we just talked about, our customers, as they're looking at their targets to reduce their emission footprints, the clock is ticking. And the viable technologies, the viable pathways is getting reduced quicker and quicker. And carbon capture is coming up higher and higher on the list as an absolute must-do solution for not only their installed base, but for the new units that they're going to put in going forward. So it's my worldview, my hypothesis is that when the first full-scale carbon capture plant goes on a gas turbine, I expect to see many, many more in the future.
And Cato, you're from Norway. I mean, we've been referring to the Sleipner and the Snøhvit projects for many, many years now, but they're still just very isolated examples.
Yeah, they are. But I think we see, at least from my experience, I've been working with CCS 2005, 2006 since there, and I was, there was really in Europe there was really I would say almost a crash in the whole business. But I see. I look at the future now much better. It's at least it's a different story now. I think both it's getting closer. All the targets that we have to achieve is getting closer and closer, and as closer it gets, I think people see that we need more and more of the CCS, and there's so many businesses that should you just shut them down or move them away from if you think of Europe, for example, you can't just shut down your chemical industry, your cement production, your steel production or whatever and move it away. And for many of them there is no other alternative. So if we're going to meet the targets, okay, then we need to do it, so that it's not just, we can't just put in solar and wind to make it help there. You could at least you could argue about for that for the power sector, but not for the industry. So and we see a lot of projects in this, you say, early development stage in Europe now, a lot more than we can handle in our company requests. But and so I hope they will move on and do investment decisions. Yeah.
Thank you. And Gianluca, you referred earlier to the EEPR, the Economic Recovery Programme, which provided some subsidies for CCS work. Well, that was back in 2009. So you've obviously been around a long time too.
Yeah, let's say I started my journey in CCS 20 years ago. So I've been seeing a lot of up and downs in this business. And what is happening now, it's really something exceptional. 10 years ago, if you think the EU ETS was on €5 per ton, now we are between 80, 100. And from our perspective, from Baker Hughes' perspective, we also see much more development on the storage side. Before it was more capture and the storage was just forgotten. Then in this decade, we understood you need storage first. And thanks to Northern Lights, we're going to have someone paving the way for others in Europe. But that is an important sign that there is much more momentum in storage. And in Europe especially, we have seen many license rounds being awarded in the last year or so. So very positive in terms of development of this business.
Thank you all three of you for illuminating us with about the technology and the potential for the technology. So you've been listening to Cato Christiansen, the Chief Technology Officer with Capsol Technologies, Jeremee Wetherby, Project Manager for Energy Technologies with GE Vernova, and Gianluca de Federico, Leader on CCUS Demand with Baker Hughes. I'm Chris Davies of CCS Europe, and thank you very much for listening.